Good morning, ladies and gentlemen, and you're all very welcome to webinar number 30 in the Irish Bioenergy Association webinar series. This morning, our topic is MyGug, microscale anaerobic digestion, a food waste solution providing renewable energy gas to small business and households. And we're delighted that you can join us this morning for our webinar. My name is Sean Fine, I'm the CEO of the Irish Bioenergy Association, and we look forward to presenting to you this morning. Just before we begin, a few very brief introductions to our organisation. So we were established in 1999. We're the representative body for the Irish bioenergy industry in the island of Ireland. We cover many sectors across biomass, biogas, biofuels, biochar, wood fuels and energy crops. Our role is to lobby, advocate and develop the sector, work with our members and external stakeholders to improve knowledge and encourage activity within the sector. We have a broad and diverse membership and open to discussing membership with anyone that's on our webinar this morning that would like to become a member of the organisation. And we roll out a number of research and development projects as well as the wood fuel quality assurance scheme. This is webinar number 30 in our series, so a wide diverse range of topics covered to date. So just a reminder here to any members or stakeholders present on our webinar this morning that would like to present as part of our webinar series. If you could get in touch with myself or my colleague Teresa O'Brien, we'll be happy to discuss further with you. This morning's webinar, we're hearing from Kieran Coffey. Kieran is the Chief Technical Officer with MyGug Limited. And we'll also hear from Noel Gavigan, my colleague, who is the RBA Technical Executive. There is an opportunity for you to ask your questions. We encourage you to use the Q&A tab at the bottom of the screen, and we'll endeavour to answer as many questions as possible. So just to take the opportunity to introduce our next webinar, a slight change in our format in that we moved to a Tuesday from the Wednesday because of the SEI Energy Show taking place on the 30th and 31st of March. So Tuesday the 29th of March is our next webinar, and we will be launching at that webinar our wood fuel quality assurance scheme animation video, and we will be talking about the topic of sustainability from a wood fuels perspective and sustainable forest management as part of that webinar. Full details will be published through our social media channels in the coming days. We encourage you to register for that webinar and participate in that. So to introduce this morning, introduce our speaker. So Kieran is a mechanical engineer, has been involved in the design and the of wastewater and wastewater treatment plants for over 25 years. And most recently, Kieran and his team has been involved in the design of a microscale anaerobic digestion solution. So Kieran will present his innovative solution here, which addresses the issue of food waste, giving you renewable energy for your cooking, but also it's a food waste treatment system that will integrate into a household, but also into a business. It's a fossil-free solution to disposing of food waste, and it does turn food waste into renewable energy, and also a biofertilizer, which can be used in your garden to grow your vegetables and your plants. So this morning, while we focus in a lot of our webinars on the medium to large scale and also the small scale, we're speaking about a different scale of anaerobic digestion today in terms of microscale, and it just shows you the versatility of the technology to address challenges at all levels. So I'm going to stop sharing, Kieran, and I'd invite you to begin. And thanks very much for taking the time out to participate this morning, Kieran. So over to you.
Thanks everybody for joining us this morning, and I'm delighted to present our microscale anaerobic technology to you here this morning. And the first question I want to answer is why Microad? Why would you choose Microad? And to understand, firstly, about food waste, you need to know where it comes from. And there was a very interesting report done in the European Union a number of years ago, and it showed where all the food waste emanates from. And interestingly enough, and interesting for us on our micro scale, most of the food waste comes from households, 53%, and 12% comes from food service. So 65% of all food waste comes from small settings like this. And this represents 88 million tons of food waste, this chart. So, and households represent 47 million tons of the total. So providing a micro scale solution will create a micro circular economy. So it'll enable our customers to create their own micro circular economy. And it's a full solution to food waste, as I'll explain in a while. So it will minimize and get rid of your transport requirements. And the beauty of anaerobic digestion is that you capture the value of the energy that's in your food, and you can use it locally in the form of biogas. You also harness the organic and the nutrient value in your food, and you can reuse it locally. And there's a big issue with soil health in the world. This will improve your soil health, and it'll sequester carbon. And one key issue for us is that when you treat locally, you will not get contamination of plastics and other wastes, deeming them useless as well as the food waste. So this is a very important point as well. And with all of these, the above, everything will reduce fossil fuel, your own fossil fuel dependence. So anaerobic digestion versus composting. What is the difference between these? On the top right-hand corner, we have our domestic micro-scale anaerobic digester, the MyGug. And at the bottom, we have a standard composter that we were all familiar with. Now, as I said before, the big difference is that you get a gas from your digester that you can use locally to cook. And the domestic digester can give you up to 80–90% of your cooking gas requirement. And instead of a solid compost waste that you get from a composter, you get a liquid fertilizer that you can pour directly on your plants and vegetables. Now, also one huge difference between the two is that MyGug is a full solution for food waste. It'll take cooked, uncooked meats, it'll take liquid waste, whereas the composter is only a partial solution to food waste. This chart here is from a UN report that was done a number of years ago on food wastage footprint. And the big items here, the food groups that are creating the biggest problem in the world are meat, milk, and grains. And you can see the requirement for water for meat, milk, and grains, and the biodiversity and ecosystem cost associated with these foods. And one of the things that MyGug will do very well is take these types of foods and digest them and convert them into heat and energy in the form of the biogas and then a nutrient. Now, when we think of food waste, we don't normally think of liquids as a food waste, but it in fact is. And you can harness, you can get the energy from that milk and use it locally. So just to summarize, a Microad will accept all types of food waste. You don't need an additional carbon source for it to work properly. It'll create an energy source in the form of biogas. It's fully enclosed, so this is key. It won't attract rats or vermin or flies, and it'll provide a constant supply of fertilizer. And like I said, you can use, you can put in all sorts of liquid waste, soups, yogurts, milk, whatever. Now, the food waste industry is highly dependent on transport, and we want to break that link with transport. And to look at this, we want to look at another industry from the past, and that was the ice and cooling industry. So back in the 1800s, it was common to harvest ice from the large lakes in Northern America and Norway and transport that ice worldwide. And it was used in these types of cooler boxes to keep food cold. The industry then developed in the mid 1800s, and there was an industrial ice making was invented. So there was less requirement for transport then, and these large ice factories were introduced. But there was a major change happened with the introduction of the fridge in the 1920s. And over the next 40 years, the dependence on transport to transport ice around the world was completely eliminated with the invention of the fridge. And this is the timeline. And so basically in the 1920s, the fridge was introduced, and that completely changed that industry. If we look at this chart here, in the mid-20s, nobody had any fridges, and then between 1930 and 1960 went from practically 0% up to close to 100% of people using fridges. So this is an example of where a micro technology completely changed an industry. And we want to do the same with food waste. We want to provide a solution, an immediate solution to people to get rid of the really difficult to treat food wastes on their own properties. Now, how do we provide a reliable system? I want to look first at the system in China. China has probably the most developed industry, anaerobic digestion industry of all, and they're reported to be up to 30 million small-scale anaerobic digesters in China. And a lot of them look like this. They're a dome-style digester. They're similar enough to a septic tank. And if you imagine there's reported to be 450,000 septic tanks in Ireland, it does make sense then that there's 30 million of these units in China. So these units provide local micro circular economies in rural areas and all over China, where people can get rid of all of their organic waste, their food waste, their animal manures, etc., and then use the gas locally. Now, all of them are quite large, and they wouldn't suit Europe or the US. So to allow a system like that to work in Europe, it had to be miniaturized. And we've miniaturized it by insulating a tank similar to the fridge, where you had basically an insulated container. We've insulated our digesters. We've provided heating, and we've also provided a huge amount of technology where we monitor the level in balance tank. Once the food waste is macerated, it goes into this balance tank, and we dose the food waste from this balance tank into our digesters. We monitor and maintain the temperature in our digesters at ideal temperatures, mesophilic temperatures. And then we monitor the whole process. So we can monitor remotely, and we can help our customers if they have any problems. And we are basically harnessing the power of the Internet of Things with our technology. So I'll just show you a video of the unit, if it'll expand for me. So I'll start that again. So this is our domestic digester, where you take off the lid and you dispose of your food waste in and macerate it. Goes into a balance tank. The gas comes out the end of the unit, goes through a moisture trap, and then it goes through a bubbler and a filter. And the egg is obviously where the digester is and all the digestion takes place. And then there's a hose at the very left here. You can see where the liquid fertilizer comes out, and you're able to harness that. We provide a range of digesters, not just domestic digesters. The domestic digester will treat about half a ton of food waste per year, but we have solutions to up to about 15 tons of food waste per year. As you can see here, the arrangement is slightly different with a kiosk and a sink and a larger egg outside, but the concept and the functioning of it is the exact same. We'll get past this, sorry. So some of the normal questions that we get asked are, is it safe? How much food waste will it accept? How much gas will it produce? And will it heat my house? And why is it egg-shaped? Now the unit, the gas is fed into a biogas bag, and the biogas bag is at atmospheric pressure, so there's no danger of that gas leaking into your house. Like when you have a gas cylinder, it's under enormous pressure. So if you have a leak in your house, it will release the pressure in the cylinder will force the gas into your house. That will not happen with a domestic scale anaerobic digester. Our domestic digester will treat 1.5 kilograms of food waste per day, about just over half a ton of food waste per year, and it will produce 3 liters of liquid fertilizer that you can use. The unit itself, the other questions we ask, will it heat our house? We are really focused on using the gas to replace common cylinders, so we're focused on using it for cooking. It's egg-shaped because the egg is ideal for mixing, and mixing is very important in anaerobic digestion. Now, I'd like to show you a video here of the real benefit, and this really highlights the micro circular economy nature of our technology. The digestate that comes from our MyGug is used. It was used in here in this polytunnel, and it was used to grow all of this food locally. And again, the micro circular economy is you remove transport, you remove your dependence on outside sources, and you use what you have to create food locally, and you don't have to use, you know, fossil fuel fertilizers, and the health of your soil is really, really good, and it will produce tomatoes like this, vegetables that you just go and pick that are 20 minutes from your door. You bring them in and you cook them. This is what our micro circular economy is all about, and the tomatoes and all of the vegetables that we produced here served us for 3-4 months when we put them into the freezer to store them, and we were able to use them well into the winter time. So this really sums up what we are trying to achieve with micro circular economy, giving people a full solution for all the different types of food waste that they produce in the home. And we've been working very closely with the fabricator, and we're going to be sending the blue unit over to the UK in the next couple of weeks, and the green egg on the left is our domestic digester. That's the size of the domestic digester. So I'd be delighted to take any questions that anybody may have, and thanks Sean and Irbia for inviting me to talk today. Thank you.
Okay.